So for the next talk, we are actually gonna talk about great security practices regarding TypeScript. And for that, we are hosting online with Abdullah here. So hello, Abdullah. Hello from all of us. How are you doing?
Hello, everyone. Thank you so much for attending this talk. Unfortunately, due to a series of unfortunate events, I couldn't make it to be there. But the Heapcon team were far too kind and allowed me to present this online. So yeah, let's go through it. Let me say a phrase that you are used to. Let me share my screen. Okay, so let's just get started. Safeguarding large-scale projects, navigating TypeScript security pitfalls. When I kind of arranged this topic or what I wanted to talk about, I was working at TikTok back then. So yeah, it might be some little differences from my current job. I moved jobs recently. So yeah, I'm just wanted to tell you about that. And yeah, this talk, basically, I will go through different things. I will introduce myself first to, convince you that I know what I'm talking about. The second thing, we'll talk about JavaScript and TypeScript, just to, set the ground for what's coming next. Then I'm going to talk about the common security vulnerabilities that I've noticed through my career when it comes to TypeScript kind of frameworks or code that I've reviewed before. Then we're going to have some takeaways that could help you to, escape these pitfalls. And furthermore, I think we're going to have some time for Q&A. Unfortunately, I cannot see anyone there, so it's kind of one directional right now. But if you have any Q&A, feel free to reach out to me, or maybe we're going to talk about it at the end of the talk. So yeah, let me tell you a little bit about myself. So my name is Abdullah Al-Sultani. So I work as a senior security engineer at MetaMask, the cryptocurrency wallet. If you're, interested in crypto, you would know that. Before that, 3 months ago, I used to work for TikTok as a product security engineer. I worked there for 3 years. Done a lot of, stuff related to code reviewing or working closely with security or vulnerability management team to fix security issues in our products. Originally from Iraq, but I live in the UK right now. I've been doing bug bounty stuff since I was in high school. Then I, can start working in cybersecurity as an information security engineer in a few companies. Then here and there, I've done bug bounty marathons. I've contributed to open source projects as well. So this is my website. If you are interested to reach out, please feel free to do that. And yeah, let's go for the next one. JavaScript. Everyone loves JavaScript, except if you are Go developer or Java developer, C++ developer, anyone that's with strongly typed language. They don't like JavaScript for known reasons for sure. But let's just go through a simple introduction for JavaScript. I think most people know, but let's just set the ground. So JavaScript is the foundational language of the web. Everything happening right now in the web pages that you open every time you visit a website or you click upon, it's always JavaScript is involved in that. So it's very fundamental to the web that we are living in today. Oh, sorry, it's not shared. 1 second, please. Now it's okay. Now, okay, let's start from. Yeah, sorry for that. Yeah. Anyway, was the first slide. This was the second one, and now this is the third one that we are talking about. For the fourth one, yeah, let's go for the brief history of JavaScript. Start with Netscape when they wanted to add, kind of make pages more dynamic to do things instead of you have to refresh the page all the time. Then right now there's the ECMAScript, which is the standard kind of language for JavaScript, and most it was for most the scripting language, but now I think it's more involved with JavaScript. And we have the V8 engine, that was developed by Google to, like it's a runtime JavaScript engine that's used like in Chrome, I think, and I think it's even used in Node.js. I'm not sure about that, but and now JavaScript's everywhere. Like it's in desktop application, you can develop stuff with Electron. Like there's I think there are many kind of engines, like game development engines that using JavaScript as well. Machine learning with TensorFlow and other places that like JavaScript has involved now. So it's not just like about the web anymore. Like it's involved in many other aspects of tech. And the thing about it, yeah, it's like kind of it's because it's much easier to learn and do things with. But however, JavaScript has its own charm, let's say. When it comes to, because it's kind of like it's loosely typed and it's like things happen all the time in a way that doesn't make sense at all. For example, if you can see this slide, nan is not none, which is like none is like not a number. It's kind of like like a variable or like kind of data type in JavaScript. So if you check the type, it's like return false for whatever reason. And if you go to this link that I included in the slide, you can see a lot of examples that where JavaScript doesn't make sense at all for one reason or another, because it's like because it's kind of loosely typed. It changed like the variable like type to do some certain things, so the output is kind of unpredictable, and it gives you a way to write spaghetti code, like because it's not it's not standardized in a way that every team, they know what really doing that. So like someone does something and then like it's completely different result when other people do it, because different interpretation, different engines and other things as well. So that's why we needed basically TypeScript. TypeScript came to solve the JavaScript problems. So TypeScript is a superset of JavaScript that has been introduced by Microsoft a while ago. It addresses the JS weaknesses. We talked about like, it adds static typing, type checking, and other things to make sure that all these quirky kind of behavior of JavaScript is not happening in a production code. It enhanced the developer productivity and reduced bugs because it's way more, like standardized in a way that helps team to understand what's going on, from looking to the project structure or like to the data types and other things as well. And it reduced the bugs that been caused by runtime kind of values. It's going to tell you like during compilation time that this is not going to work out, so you can't fix it before actually moving it to production. It adds like the most like remarkable features. It's static typing, so right now you have to say like when you're defining a variable, what is the type of this variable? Type interface, sorry. Right now you can tell like the object of the function what's the data type that it's expecting. So if it's an integer, if it's a string or something else. And its compatibility with modern JS. So I think you can change any so the extension of TypeScript is .ts. And I think you can change any .js to a TS. It's going to be working. Don't do that in production. It's not like a recommendation for me, but I think it was the case like a while ago. And complication safety. So when you like we talked about compiling the code that you are doing, it gives you safety because you can actually find errors before compiling your project to send it to JavaScript. And why I say compiling, like you'd be like, okay, is it why we need a compiler in the first place? Because this is what actually happens. So since we said TypeScript is a kind of superset of JavaScript, so it has JavaScript, it has like the ES6, which is like more like the extended one. And there's like, interfaces, strongly typed, and generics that's been introduced into TypeScript. So when you actually write the TypeScript code, you don't write TypeScript, like, eventually will be compiled to JavaScript because your browser cannot understand TypeScript. It can only understand JavaScript. So yeah, like it's called kind of, transpiling like the code from TypeScript to JavaScript to be run everywhere else. I took this image from this URL. We can take a look at it as well. I'm just checking if we are on time. Yeah, so this is the part when it comes like, the interesting things. I just want to state 3 things that I didn't share everything I've been stumbled upon for, like security reasons or stuff that I cannot disclose. Second thing is there are more than what I'm going to talk about. There are other security issues, but these are the most common ones. And the code snippets here is just like, pure examples. Like it's not actually any code snippets that I found, in production and I copied it. So I just tried to, made up these examples to give you the bigger picture. So the story time, as I told you, I've been working for 3 years at TikTok. Like most of the code that I was reviewing was in TypeScript. And for that reason, I came to find a lot of these issues that I'm going to talk about right now. So everyone knows what's cross-site scripting, but I will assume that you don't know. It's just like a way that when you're taking user input and just redirect it or output it in the HTML page. For example, look at this snippet here. We are taking the name from the URL, then we are injecting it like saying hello, the name, but we are doing this into the DOM, which is like the inner HTML. And now if someone comes and put the name as as like an HTML tag with like a script tag, it will actually look something like that. So they will be able to inject JavaScript code into the page and execute their JavaScript in our own like origin or host. It's a very common problem. There's a lot of solution for it. It's been here since like, I don't know, the 90s maybe. It's a very common problem that I think most like website used to suffer from, but now it's to less extent. And when it comes to cross-site scripting in frameworks, so when frameworks like React, Vue, Angular, and others try to make a way to write secure JavaScript code. So if you can write most of these things in TypeScript, and this is like the way right now. So most of these frameworks been written in TypeScript. They try to make it less sustainable to cross-site scripting. So what they did, they added dangerously set inner HTML. So it's in the function name itself. It tells you what are you doing right now is very dangerous because you are setting the inner HTML from the content that you have, and it will basically be injected into the DOM. With a Vue, we have the v-HTML directive. It serves the same purpose. And with Angular, it's like the security, like this is security flag trust as HTML. So basically telling the Angular to trust this content as HTML. So if anyone has the ability to inject user-controlled input into these functions, it could be really like causing cross-site scripting. And through my career, I've been reviewing a lot of React code. I think it's the most common one. Like people use it to write front end. So this is the way of the things happen in React. It's just like you have dangerously set inner HTML with the HTML directive and then user input inside it. So if user input something like this image tag, then it's source to and found source. You can you can execute JavaScript, so you can look at the on error event. Since it's going to be an error, there is no such a source with this image. It will initiate the code here, which is going to have the alert access as in the window. This is very common. I've seen it so many times before, for one reason or another, because sometimes you actually need to have HTML code into your page that's been dynamically created, and sometimes you need user input inside it. So what is the way to, if you have such a case? Most of the time you can write the code without having dangerously set inner HTML. But let's say you need to do that. The way to make this happen is you can add something like Doom Purify. This is a link for it. You can use it. It's a package. It basically sanitizes the user input, and then you can safely inject it into the DOM. I think, yeah, one thing also I need to tell you about here is to make sure to keep it up to date, because even with Doom Purify, sometimes there are something called MXSS, which is mutation cross-site scripting. So these kind of mutation, it exploits the behavior that let's say the renderer of the browser, how it's like, parse kind of HTML code. Sometimes it generates a way to bypass this security kind of mechanism by exploiting the browser behavior. Since it's like gets updated, get like, added more things, more tags, and they change maybe the way that they parse HTML. So it produces a way to find XSS payloads that bypass these security, but it's not it's not the case most of the time. But you make sure you have to keep it up to date. Checking time. Okay. Another thing that we have here is that it's also very common, like I've seen it so many times, when developers try to build links from user controlled input. So they just have when they build the React component, they just make, the anchor tag with like the hyper reference equal URL, and the URL is user control. So if the URL, like, let's say you are making a website that tells the user, okay, you can put your social media accounts or links here. And then like the user came along and put the JavaScript scheme, like, and the colon and alert, then basically anyone that going to click that link will execute JavaScript in their browser or in their web page. So that's also like something is very common. Like I've seen it so many times before. How to fix that? Easy. So whenever you are actually like, want to view a URL, make sure it's a valid one. So you can pass it to a checking function. Look at this, like is valid URL one. It basically does this. It parses the URL. Then if it checks if the protocol is HTTP or HTTPS, then it will return like true, but otherwise it will return false. This is very basic one. Like if you can have more advanced one, if you are looking into it more, but just make sure to check the scheme before passing it. So you want to check if it's HTTP or HTTPS, because there are two dangerous ones, that is data and JavaScript. So make sure to filter for these. I will take a little bit about same origin policy because it's going to come along after this one. So the same origin policy is a critical security mechanism that restricts like how, like script loaded by one origin can interact with a resource from another origin. And what we mean by origin, it's like you should be the same scheme, same domain, and same port. That's called origin. Like, so the URL has to be the same in order to interact with like a document from another, let's say that's from the same origin. And that's it basically. And when we talk about like how they communicate, so if it's an opener or if it's an iframe, like this is the way that they can reach. So if like let's say we have like a page.html at example.com, it can communicate with example.com/example, example2 as well. So like the first two, it cannot talk to the third one because it's like HTTPS, which is a different port. It cannot talk to the fourth one because it's a different domain. Also, like it's sharing the same parent domain, but it's not sharing the same subdomain. Same for the fifth one and the last one as well. The ways to make the two documents communicate is that you have to do it through one of these ways. The first one is the cross-origin resource sharing, which is CORS. Basically, you are setting headers to and tells the browser how to interact with this document. So if you say like you can allow this origin to read from this page, then it will allow it. Another way is like they're using JSONP with JSON with padding. It's also like include the data in a kind of way of JavaScript file that you can actually include it into the page, and you will be able to extract the JSON out of it. Post message API, which is what I'm interested in, and the fourth one is like if you have two, let's say, subdomains from the same parent domain, you can make them interact with each other if you set the document domain in both pages to the parent domain. I think they want to trying to kill that. I'm not sure, but I'm not sure if they killed it or not, but this used to be one of the ways. So with the post message API, basically you can send data to a different origin, but it has to be like received from their end. this is a way to, let's say you want to talk between your website, like example.com with facebook.com. You can send them like, a post message if like actually facebook.com has an event, like, event listener on the message, and then like they check it. So one of the most common mistakes that I've faced with post message API, it's very common. It's been used like everywhere for ads, logs, authentication, and other places. The first one is no origin checks at all. So they never check the origin that this message came from, and they trust the data blindly, which is a terrible thing. Faulty regular expression against origin check, like they write a regular expression that could be bypassed easily. Insufficient origin check, I will talk about. They use different like, functions to check the origin, which are not sufficient. The first one is no origin check. Like if you can see here that in this snippet, we are reading the message from any page that, sending us like a post message. Then we are injecting the data that we received from that event to the inner HTML, which is like causing cross-site scripting. This is like, a way to exploit other things. Sometimes it's not like a vulnerability by itself, but if you are trusting these messages to manipulate the page or to send data, yeah, that could be really a problem. You can read about post-message XSS. It's like been here for a while. A lot of big tech companies were vulnerable to that before. Another one is like the faulty rejects that I talked about. So look at the trusted origin pattern, like they are using the regular expression here. So they make sure it's to start with https trusted.example.com. However, trusted.example.com.evil.com will match as well, since it starts with the trusted.example.com. So you need to make sure that you put the line terminator at the end of the domain to make sure that it's going to be matched against this one. The second example here is that we have includes, which is going to check if the event origin includes this as well, like the trusted origin. So if it starts with the origin, it also will be include, it will return true, and you will be able to bypass the security here. It's also a very common mistake that I've seen before. Another one, index of, like when you use event.origin.indexOf, you are also having the same problem because trusted.example.com.evil.com, like, the URL above actually includes the substring trusted.example.com. So it will always match and it will be 0. So it's not -1, it will pass the security check and we're going to trust this content. Another one is like starts with. So if it starts with, they check the URL starts with this domain, but you can see like in the trusted origin, it's actually the trusted.example.com. But if you send a message from trusted.example.com.evil.com will also match since it starts with trusted.example.com. Another one is ends with. So it's the same issue because not example.com actually ends with example.com. So it will matches and it will bypass this protection as well. These are the most common patterns that I've realized through my code reviews that developers use these functions to check, which are not sufficient. So what is the right way of doing things? You need to make sure that the event origin is equal the trusted origin. Like, so you have to put like, the trusted origin, and you have to make it, obviously that this is the only way that want to communicate with this origin. So you're going to lock it to like let's say you want to talk to facebook.com, so you have to put facebook.com into the trusted trusted origin, so you're not going to getting messages from different origins in the page. And also, like we talked about DOM purify, so don't like just take user data and then trying to inject it into the DOM. You make sure like you sanitize the content before pushing into the inner HTML. We have like a new technique called server-side rendering. It's basically generates the the HTML page on the server, then you send it to the client, we send it with information. It's just like the back old days when we have PHP and HTML code, but they just have like a different way of doing it right now with JavaScript. It's called SSR. So they say initial page to the user with like the data that it needs just to give like the skeleton to the page for CO and like and better user experience. So this is how it works. Like user send a request to the website, the server generates the HTML, the browser render the HTML, then download the JS and all, like, like this is the life cycle of the server-side rendering. Also, like, yeah, a lot of companies start using that. And I've noticed one common problem with that is that when you are building the HTML page, you have something called the preload state. This is how you put the JSON data into the page that you are building, like the first page that you're sending to the user. So sometimes you need, like, you have variables, or like, let's say you have parameters from the URL, you have data from the database, and you just want to send it to the user from the first, run. So they use like this kind of pattern all the time. They have this, return full page. It's an HTML page, and it has this like JSON stringify the preload state. The preload state could be user input, could be like data from the database. And if you actually have like user input with the payload above, you can see it like we closing the script tag and we added our script, like, our tag. It will be injected to the page as like, it's going to cause cross-site scripting, and it will run the alert function in JavaScript. This is the way to fix it. So you just need to replace the greater than with the Unicode, equivalent of it. So it will be escaped when it's been rendered to the HTML page. This is the common practice by all the, I think, like Next, like using this to do the server-side rendering. So they are actually telling you that this is the default way of doing it. But like when some people like build their own kind of, render or something like that, they kind of forget about this. The prototype pollution as well, that's a very common problem that I've seen. If you don't have an idea about this, so basically when you are merging like a user like controlled object with like a target object that you are interested in, the user object can override some, like prototype of that object and then cause like an issue. It's very like, interesting topic. If you are interested to learn more about it, you can go further and check the URL that I included here. This is an example I've found in Secularize, TypeScript library. They are using the same problem, like, they have the same problem. You can look at this commit. They have the object get on a property, then they copy these, like stuff to the object, and then like and when we talk about prototype, basically I will show you in the next slide what I'm talking about. Is you can include one of these, like, underscore proto constructor or prototype to override the actual, like behavior of the object. So you can add more like, stuff to it. If there is like security checks, like is admin, for example, part of the prototype, and you have a user, like controlled object that is getting merged with another object for security reasons, or like, for different business needs, and the user have the ability to add like proto constructor or prototype, they will be able to override the object and add more properties, like even if you have like filtration or you deleted it already, they can use this to make sure that they return like that property using the prototype. So that's why it's called prototype pollution. Regular expression denial of service. This is one thing that I've noticed like a while ago, is that so many applications actually suffer from this problem. So when it comes to regular expression denial of service, it's a very complicated topic. Like it's going to take a while to explain, but let's say that you have a way to, regular expression is a way, like to detect pattern in a string. So think about a case where like the user supplied input actually causing the regular expression engine to go into an infinitive loop, or like, or kind of like takes a long time to match a string, even although it's a very small string. So if you look at this, the verbal regular expression, there's like, it's mostly with nested quantifiers, and it's very hard to detect as well. So you need to make sure that you are writing like a regular expression that could be checked in linear time. So if you look at the example, the username, we put a lot of A's, then like we repeat it 10,000 times, and we put like the like the question mark, like the quotation mark, and then it will keep checking till forever. So like if you have like say a client-side application that, let's say it's a wallet or like an application that runs on JavaScript, then or TypeScript, then it will go to in a state that it will start like trying to match a string and it will crash eventually because of that. So it codes denial of service for client side, and it also could code it for the server side as well. So the way that fix it is you can just make sure that you are writing like a secure regular expression, like this one could be checked linearly, basically in a linear time. And then you can use there are a lot of tools I mentioned how to, like you can check your regular expression if it's vulnerable to this attack or not. They are not very reliable sometimes for one reason or another. Like I had my experience with a lot of them and they were not finding every single instance of the problem. But at the end of the day, you just want to know that it's like, it's better than nothing. You can use also ChatGPT. I think it's really doing a good job when it comes to detecting these patterns. And another thing that I've noticed as well is that we have a lot of projects that people think when it's compiled it will be uglified and they will not be able to, if someone actually looked at the source code, they wouldn't be able to find the private keys or the keys that they are using. So sometimes they just hard-coded API keys or secrets inside the code itself. So if like someone got like the compiled or like the one that we were thinking that it's like it's very ugly code, like some people can use reverse engineering to find the private key eventually. So the way to okay, so we have like we don't have that much time. I think we kind of almost finished. Hard-coded sensitive data, so the way to do that, you can just use like another way, for example, using the environment variables, or try to eliminate that you add any places, like any sensitive information to the code that you will be compiling. So the takeaways here are, with the cross-site scripting vulnerability, like in major web apps, just like, we talked about using these frameworks that are, like well protected, but you make sure you're using the best practices to not use like, a function that could cause cross-site scripting. For the post message, when you are interacting with a foreign origin, you have to make sure that you are talking to the origin that you are wanted to talk to and not make it very lax or using partial matches. For the hydration exercise, which is like the server-side rendering, when you are building the page and you are returning the JSON variable, the JSON data, make sure you are filtering for greater than sign, so you don't cause the escaping from the JavaScript tag, basically. The prototype pollution, you can read more about it, but make sure like when you're trying to merge like, two objects to not cause this issue. Regular expression that slows down the application or like, it can kill it sometimes. Make sure when you are writing like, Java regular expression in JavaScript to make sure that it's not vulnerable to this kind of attack. There are a lot of checks. You can check Redos checker on Google, and you find a lot of tools you can use against it. This is the case for JavaScript because the engine actually has this problem. So in Golang, for example, we don't have this problem because they use regex2 or RE2 engine. So it does not backtracking into it. So it doesn't cause this behavior that you go into a lot of matches like with a small string. And for the sensitive data, keep the sensitive data out of the source code, like when you are writing TypeScript code, and use like either environment variables or secret management tools. Q&A, I'm not sure, can we take Q&A or not?
We have time for one question if anybody has it. Any questions? I think that's it. I don't see questions from the audience. So thank you very much, Abdullah, for getting the time to be with us. And let's have a round of applause for him.
Bye-bye.